All right, today we're diving deep into the bedrock of Java. We're talking about the tools that let you build software that doesn't just work on a good day, but can actually anticipate problems and handle them with, well, a bit of grace. Let's jump in.
You know the feeling, right? We've all been there. You're right in the middle of something important, you click a button and poof, the whole thing just disappears. Maybe you get some bizarre error message, maybe you get nothing. It's just gone. Super frustrating, and it's basically what happens when a program runs into something it was never told how to handle.
Look, the truth about writing software is that things go wrong. It's inevitable. A network connection will drop, a user's going to type ABC where a number should be, a file will vanish. Instead of just crossing our fingers and hoping for the best, Java gives us this really powerful system to actually plan for these problems. And that's exactly what we're going to break down. So, first things first, how does Java even think about these kinds of runtime problems? Well, it has a specific name for them and a whole system built around it.
In the world of Java, when one of these unexpected things happens, it's called an exception. But here's the cool part. It's not just some error message, it's an actual object that gets created the instant something goes sideways. This object is then thrown, and it carries all this useful info about what went wrong and exactly where it happened in the code. And this right here shows you just how organized Java is about its problems. At the very top of this whole family tree, you've got throwable. Now, it splits into two big branches. On one side, you have error. Think of these as the catastrophic system-level failures, like the program running out of memory. There's not much you can do about those. But the other branch, the one we really care about, is exception. These are the problems you absolutely can and should plan for. Things like a file not being found or a network timing out.
Okay, so we know these exceptions are going to happen. How do we stop them from blowing up our program? Well, Java gives us this fundamental tool, kind of like a safety net for our code.
And this is it, the try-catch block. It's honestly brilliant. You take any piece of code that you think is a bit risky, code that might throw one of those exceptions, and you wrap it inside the try block. If everything goes just fine, the catch block is totally ignored. But the moment an exception is thrown, the program's flow immediately jumps over to the catch block. It literally catches that error object, giving you a chance to handle the problem gracefully instead of letting the whole app just die.
But try and catch are really just the start. To become a pro at handling errors, you gotta know the full set of keywords Java gives you.
These 5 keywords right here, they make up the entire system. We've got try and catch, our safety net, but then we've got finally, throw, and throws. These give you much finer control over how errors are managed, from cleaning up your mess to basically creating and announcing your own potential problems.
Okay, let's clear these two up because they trip people up all the time. Using throw is like pulling the fire alarm. You are actively, right now, inside a method, triggering an exception. You're saying, something's wrong, stop everything. On the other hand, throws is like putting a fire hazard sign on a door. You're not starting a fire, you're just warning everybody. Hey, anyone who uses this method, just so you know, it might throw this type of exception, so you better be ready for it.
And then we have finally. This is the cleanup crew. And the most important thing to remember is this: the finally block runs no matter what. It doesn't care if the code succeeded, if an error was caught, or even if there was no error at all. The code in finally is guaranteed to execute, and that makes it absolutely essential for things like closing a file or shutting down a network connection so you don't leave resources hanging.
So what happens if a method causes an exception but doesn't have a catch block to handle it? Well, it bubbles up. Let's say an exception happens in method M. If M doesn't handle it, the exception gets passed up to whatever method called it, in this case N. If N doesn't handle it either, it goes up again, to P. This keeps happening all the way up the call stack. If that exception reaches the very top and still nobody's caught it, that's when your program crashes.
All right, let's talk about where this stuff becomes absolutely critical in the real world. And the most common place by far? When you're dealing with data from outside your program. You know, like files and network connections.
So in Java, we use something called a stream to manage all that. The easiest way to think about a stream is like a data pipeline. It can connect to a file on your hard drive, a website on the internet, or even your keyboard. And it lets data flow in or out, one piece at a time. And right here is where these two big ideas collide. Talking to the outside world is just unreliable. The file you want to read, it might have been deleted. The network you're trying to use, it could drop out at any second. These are the perfect scenarios for exceptions, like file not found exception. And it's why pretty much any time you work with files or networks in Java, the language forces you to use a try-catch block.
And wow, does Java give you a lot of tools for this. Now, you don't need to memorize every single one of these classes. The big takeaway here is that there are two main categories. You've got byte streams for handling raw binary data, think images, audio, that sort of thing, and then you have character streams, which are specially optimized for handling text. Picking the right tool for the job is super important for making sure your data doesn't get messed up.
So up to now, we've been focused on being reactive, catching errors after they've already happened. But what if we could be proactive? What if we could write our code in such a way that an entire category of errors becomes completely impossible to begin with?
Seriously, think about this for a second. In the old days of Java, a list could hold anything and everything. You could have a list of numbers and accidentally drop a piece of text into it, and you wouldn't find out until your program was running and it tried to do math on that text, and then crash. So how do we prevent that?
The answer is generics. Generics let you create components that have type parameters. So instead of a plain old list, you create a list of string or a list of integers. You're basically telling the compiler up front, hey, this list is only for strings. And this gives you two massive wins: type safety, and you no longer have to manually check and convert types all the time.
And this slide just says it all. On the left, you've got the old way, a ticking time bomb where anything can get mixed in, just waiting to cause a crash when the program's running. On the right, you've got the safe, modern way. If you even try to add an integer to your list of strings, your code won't compile. That's the magic right there. You've taken a nasty, hidden runtime bug and turned it into a simple error that your tools catch for you instantly. So let's tie this all together now. These three big ideas, exception handling, I/O streams, and generics, they aren't just a random collection of features. They truly are the bedrock of writing reliable, professional software in Java. I mean, take something like serialization. That's just the fancy word for converting a whole object into a stream of bytes so you can save it to a file or send it across a network. To do that, it has to use I/O streams. It absolutely requires solid exception handling in case the disk is full, and modern versions use generics to make sure everything stays type-safe. You see, they all have to work together.
So if you remember anything, remember this. Exception handling is your plan B, your reactive safety net. I/O streams are the essential but totally unpredictable pipelines to the outside world. And generics, well, that's your proactive offense, letting you design code that wipes out entire categories of bugs before you've even written them.
And that really brings us to the final thought here. These tools, they do more than just make our code safer. They're what make modern software possible at all. Think about massive web servers handling thousands of requests, huge data processing pipelines, complex financial systems. Without these rock-solid ways to handle errors, manage data, and guarantee safety, those systems would be way too brittle to even exist. It just goes to show you that a solid foundation isn't just a nice feature, it's everything.